Greetings and hello and welcome to the second Appear podcast of 2024. My name's Andy Rayner. I'm the CTO of Appear, and it's very good to be with you. I am joined by two of my esteemed colleagues. First of all, we're going to go all the way over to the west coast of the US. I'm in the UK. We're going to go over to Ed. So Ed, I want you to tell me what you do in Appear and where exactly you are, and also what your favorite ice cream is.
That's great. Well, thanks for having me. My name is Ed McGivern. I am the general manager of North America for Appear. We are based in Woodland Hills, California, which is just outside of Los Angeles. And I would say that my favorite ice cream maybe is more of a gelato and coconut cream. Anything coconut.
Very good. Very good. And then the other way over to Oslo. Terje, tell us the same things from your perspective.
Hi, Andy. So I'm in Oslo. I'm an FPGA developer. I've been working for Appear for 14 years now. And my favorite ice cream is strawberry.
Wonderful. Okay, now we've got the important bits. We're going to dive into the topic for today, which is looking at the use of SRT, or more generically ARQ technology, for connectivity for high-profile broadcasters. And I really want to explore this because this, from my perspective, is something that's really exploded just in the last 3 years or so. So I think probably it would be good to start with you, Ed. Can you give us your market perspective on SRT and how that has really taken off in terms of end user demand?
Yeah, absolutely. I think the biggest driver, in my opinion, was the onset of the need for REMI production. And when I say the need for REMI production, I think it really kicked into high gear when we were in COVID and lockdown. Sports were not happening, but I think once it did come back, there was a big need not only to do, partial REMIs with things like taking EVS off of trucks and making those remote, but also doing full REMIs, right? And so I think the technology of sending camera feeds back and forth to NOCs from remote production sites was always something that I think the engineering teams knew was possible, right? But was missing this, kind of the security across the open internet.
Yep.
And then, once we start getting into full REMIs, then it starts to become an enterprise type of an application. We start taking these cloud workflows or these remote workflows from islands, and we have to now build them into the enterprise. So we need something that integrates with the workflows that are part of the network chain, right? And the scalable SRT gateway that we launched last year at NAB was really a game changer.
Yeah,
where we could do multi-signal flows from remote productions and things back to do full production REMIs.
and you mentioned a key word there, talking about the broadcasters and content producers looking to use public internet or open network connectivity as well as the traditional private leased lines. So that's a change that's driven some of this requirement, I think.
Yeah, and a lot of what we're seeing is a lot of people are using SRT and open internet for for backup, right? So they have a private line network, but they're also using SRT as their backup signal path.
Yeah, very cool. Very cool. Okay, jumping into the technology a little bit. So I'm going to move over to Terje for a minute. So I know we actually considered looking at ARQ technology within the X product probably like 5 years ago or so. But tell me, when did we actually do this development? And can you tell me what is special about the way we've implemented our SRT technology compared with how other people in the industry have done it?
Yes, we first had this software-only solution based on this open source library running on our CPUs. We had that for some years, but that couldn't really give us the performance and bandwidth that we were looking for. So we were starting to look into what can we do to improve this bandwidth, basically. And we considered buying a more powerful CPU, but that requires more power and it doesn't really. That also meant new hardware. So we decided to go into an FPGA acceleration using existing hardware that we already had in the field. So we redesigned, we implemented this from scratch, partly in software and partly in FPGA.
Cool. And so you talk about implementing an FPGA. Obviously, that means we can scale speed significantly. Can you give us some example of this kind of speeds we can achieve with the implementation that we've done now?
Yeah, so with this FPGA implementation, we can do up to 6 gigabit in total per module in our X platform, and we can do up to 3 gigabit on a single flow. So
Wow.
one SRT connection can be 22.6, so it can be JPEG XS.
Yeah.
It can
So we can do uncompressed or lightly compressed, as well as the traditional SRT technology stuff, which would be an AVC or an HEVC.
That's correct.
Yeah, cool. And Ed, that's the thing that's given us a lot of traction in the market with this technology, I believe.
Yeah, absolutely. Because with that architecture and being on FPGA, you can route any signal out, an HEVC decoder or transport stream over IP. You can route an SRT flow, and a lot of people have taken a look at this architecture and decided, I could actually use JPEG XS and put this into my SRT gateway. To clean up maybe even some private line networks. So if you have some bitrate drops on your private network using JPEG XS, you could also route that XS stream out an SRT gateway. And with our bandwidth capability that Terje has talked about, that's completely doable. We have a customer that does 400 megabit flows, 8 flows out of a truck to go up to AWS. And using SRT on the internet was actually cleaner and less drop packets than using their private line network at one point.
Yep, very good, very good. Now, obviously, we support a variety of protection technologies within the Appear estate. So the ARQ technology we're specifically talking about today is one, but obviously we do the RTP merge technology, as I call it, which is -7, 2022-7, and we also do FEC in applications as well. So we've got this plethora of protection tools. But when it comes to the ARQ specifically, Terje, I know that lots of people are saying, why SRT? Why not one of the other options? What was your view for the reason we took that decision, which is obviously was before my time in Appear?
So ARQ is a good fit for internet, I think, because the noise level is very random and very unpredictable. FEC, for me, is very suitable for kind of predictable constant noise like we have in SOX satellite transmission. And there's 7, that means cloning. You need to duplicate every packet. It's a 100% overhead. So ARQ is kind of in between. You only resend what you need. There's no wasted bandwidth.
Yep.
On the cost of the latency, of course.
So personally, I've been passionately working on RISC technology, which is another ARQ technology. But SRT, although it was a single vendor solution that was opened up to the market maybe 4 years ago, has become really the de facto solution. And I think that's what's being demanded by the industry. Is that what you're seeing, Ed?
Yeah, absolutely, and especially when you talk about the 22-7 and and that resiliency across our SRT gateway. That's really the linchpin, because now we can take applications or from these bespoke island architectures and now bring it into the enterprise, right? So now there's some fault tolerance across that and FEC, and you can adjust the amount of retran time to accommodate longer links across a WAN and things like that, or across the globe. So yeah, that's been a really big game changer. And I think, SRT, a lot of people talk about, RIST for port tunneling and things of that nature. But for the most part, I think SRT has really been the de facto standard in deploying large scale.
Cool. So just jumping again back to the tech for a second, latency. Now, latency is always a question here because whilst this technology obviously is able to pretty well clean up within bounds in anything that you throw at it, there is a latency penalty for doing that. So Terje, tell me the range of latency settings that that we see end users looking to use. I think there's quite a big range depending on the use case.
Yeah, so we have seen everything from 100 milliseconds up to 4 seconds, basically depending on if it's a private network or the public internet. So there's a big range, and it also but it's usually 2 to 3 times the round trip time. Sometimes you want to go even higher to cover burst loss. If you want protection against big burst, you need a big latency.
Yeah,
basically.
And Ed, in terms of the end user applications for this, can you give us 1 or 2 examples of where people are actually using this tech?
Yeah, I would say partial or full REMI applications. We did I was actually at the UFC in Memorial Day weekend last year at the Apex, and we were actually, there was matches in China, and they used full SRT over open internet to take all the cameras back and did all the productions in Las Vegas and the Apex. So, that would not be possible without this type of technology. And, as I mentioned before too, being able to scale large bandwidth through an SRT gateway for, accommodating packet loss. And then also, for ground to cloud and cloud to ground applications for play out and live production. We've been successful working with some major networks across the U.S., both broadcast station groups and networks, and also a network in Canada where they're deploying SRT enterprise to be able to do all their play out functions from multi-regions. And they've chosen the Appear SRT gateway to standardize and build out their entire infrastructure for that. So those are some great use cases that people are using real world applications for. Cool.
Diving into how it works under the skin, and also again our implementation, Terje. I think in my mind there are 2 very clear elements in SRT. There's the media data flow, and then there's the control elements of the messaging about what's happening. So when we embarked upon this and looked at the implementing it in FPGA with obviously some CPU stuff involved. Tell me about that kind of distinction and our journey of implementation there.
Yeah, so the starting point was, of course, the X platform with the 10G capable I/O modules that can do TS processing, muxing, demuxing, and RTP mapping of 2110. So we can have this engine that could do all this. And then we wanted to add the SRT layer on top. Then we started with the natural choice that the FPGA controls or implements the data plane with all the data packets, and we did all the control packets, the control logic in software. So that's where we started. We honestly thought that would be sufficient to get these bandwidths, but it turned out that there was still a lot of traffic going to the CPU and a lot of communication between the CPU and FPGA. So we had several iterations to kind of improve this to get the bandwidth that we wanted, and we ended up accelerating more parts. So parts of the control plane is now also in the FPGA to kind of offload the CPU.
Cool. So we have a uber optimized solution to give us the multi-speed that we've been looking at. Also, it's worth saying that the payload, from a security perspective, the payload can be encrypted or scrambled as part of this. What technology is used for that?
As with SRT, they're using AES in the counter mode with the two different. We have a 128-bit key and 256-bit key, and this is one of the biggest. One big benefit with FPGA is that when you enable this, there's no impact on the bandwidth. There's no additional load to the system, as opposed to our software doing the same thing. So when we do 256 to scrambling, we get the same bandwidth as without any encryption.
Yeah. So wire speed performance, and Ed, I think you from your perspective, our solution seems to have hit not only a sweet spot, but also is quite unique in the marketplace in terms of what we can actually offer customers here.
Yeah, it is. Instead of being tied to an encoder or decoder for SRT bandwidth, to be able to have, a modular platform where you can route many signals, whether that's, RF to a transport stream and out SRT, it gives so much flexibility, and the scalability on the FPGA, as Terje was talking about, is really it's a differentiator. It's a very unique approach to how we come to the market, and customers certainly have seen that this scales. This is something they can deploy at scale on an enterprise, and that's been warmly welcomed.
Very good, very good. Yeah, one other little technical point here. I mean, one of my, I guess, my frustrations of SRT versus RISC, talking purely techie dirty here, is the fact that SRT is not RTP compliant at its outer layer. That's kind of the frustrating divergence between where RISC went and where SRT has gone. But that being said, I think one of the elements we're looking at in the future, Terje, is the implementation of -7 alongside SRT, and we've got a couple of different kind of chicken and egg situations, I think, in terms of which element comes first. So the adoption of the concept of doing an SRT layer healing and then allowing a -7 merge versus doing effectively an RTP merge before you actually do an ARQ. Can you outline kind of those scenarios, and do we want to do either of them or both of them moving forwards? What's your thinking there?
So from a technical standpoint, these are almost the same thing. We need to merge two paths, and it's based on sequence numbers, and both in RTP and SRT, just what numbers do you use. But there is a technical benefit of using the SRT defined, they call it broadcast bonding, but it's basically the same. But then you do the -7 healing first, and then the ARQ afterwards. So it will reduce the need for ARQ a lot. Whilst if you do the SRT layer first and then you do the -7 downstream, then you need to do ARQ first for two separate paths, and then you do the merging later. Yeah. So we see the need for both, because some customers prefers the RTP. They have an RTP clone in the encoder upstream, so they don't have the cloning on the SRT level. So we might want to do both, but it's a constant debate what to do first.
Cool. Okay, that's good. And one other future thing in on top of our already well featured capability here is do you want to outline this multiple caller to a single listener stuff that we're actually adding in?
Yeah, that's a feature we will work on this year. That's to allow output modules to be configured as a listener, and then allow multiple callers to call in to the same UDP socket, and then we will automatically copy the data and send to each of these destinations without any user input on the TX side. So we will kind of automatically enable multiple callers to call in and get the same feed, which will, yeah.
Great. So, thank you, gentlemen, for unpacking that a little bit. Ed, any closing observations from the customer or end user perspective of this technology you'd like to share?
I would just say that, this really enables future state workflows, and it allows, organizations in live production to be able to manage these workflows, systemically and from an enterprise. So I think our approach, according to our customers that have adapted it at a pretty rapid rate, would agree with our architecture and moving forward. It's scalable, it's robust, it's secure. The fact of doing link bonding and 22-7 protection and FEC is just key. So I think we're right on point there.
Wonderful. Thank you. So, Terje and Ed, thank you so much for having a little chat with us today. It's really appreciated. And if anyone out there wants to discuss further, we'd love to talk about the tech and also how we actually go to market with this. So, do get in touch and do stay tuned for our third podcast, which will be coming up in March. But in the meantime, happy February, everyone. And thanks for joining us. Take care.